What's up, guys? Today we're gonna play Body VR. But let's get started in the video.
Our journey begins here, inside a blood vessel, carrying blood from the heart. Let's take a closer look. We are currently on the outside of the macrophage, within an infected tissue, looking at its surface. A typical cell membrane structure. There are thousands of receptor protein on the surface of the cell. Some of these proteins are tasked with transferring information, and others with transferring cargo. Water and oxygen pass freely through the cell's membrane. Larger molecules, like glucose, enter through small pumps or channels.
Larger? Oh.
Large objects, like viruses, require recognition or keys to gain access, thus preventing unauthorized entrance. Fortunately, I have a counterfeit key that's identical to a real one. We are now entering the cell. A macrophage has pulled us in, and we are submerged in the cytoplasm, a gel made mostly of water. The cytoskeleton is made up of a network of adjustable strands that gives the cell its structure. There are 3 different types of strands that make up the cytoskeleton. Microfilaments are the thinnest strand, measuring only 7 nanometers in diameter. Intermediate filaments are made of the protein actin and have a diameter of 10 nanometers. Lastly, microtubules have a diameter of 24 nanometers, which is wide enough to be used for transport.
Oh my god. It's just a picture.
A special type of protein, called Kinzin motor protein, has the ability to walk along microtubules, latches into larger structures, and transports them around the cell. Energy is available in the cytoplasm in the form of ATP molecules. ATP binds with Kinzin and propels it forward. With each step the Kinzin takes, it binds with an ATP molecule and releases an ADP molecule. In real time, Kinzin walks up to 100 steps per second. The kinesin protein is heading straight for the cell's nucleus. Let's tag along for a ride. We are now approaching the nucleus, the center of the cell.
Sama ini dia.
The surface of the nucleus has its own membrane, similar to that of the cell. Pores are spread around the surface of the nucleus to allow entry and exit of larger molecules. Protein filaments are located around the edge to facilitate the transport.
Come here. Some of it might be gross for you guys.
Let's head inside.
No, thank you. According to
Here
me.
we are inside the nucleus, the control center of the cell, containing the majority of the cell's DNA. DNA, or deoxyribonucleic acid, is a molecule that carries our genetic code.
Take a piece of it out. Your DNA changes.
The DNA contains instructions for protein synthesis. In the process of transcription, a segment of DNA is copied into RNA, or ribonucleic acid, containing a single recipe for protein creation.
No.
Let's exit the nucleus through a nuclear pore.
Oh no. Oh no.
We have exited the nucleus and are now floating through the cytoplasm. Surrounding the nucleus is the rough endoplasmic reticulum, or RER, a maze-like structure made of flattened membrane. Studded with ribosomes, the RER maintains a vital role in protein synthesis. Ribosomes link together amino acids, following the instructions received from the RNA.
That is a picture.
The protein is then transported in a vesicle made from a portion of the RER's membrane.
Protein.
In the distance, you can see a mitochondria. Mitochondria are free-floating organelles, typically referred to as the powerhouse of the cell. Mitochondria received its name due to their vital role in ATP generation. ATP, or adenosine triphosphate, is the main source of energy within the cell. Mitochondria take the pyruvate and convert it into carbon dioxide and water, releasing ATP in the process. Now that we have seen the major components of the cell, let's make our way outside.
I hate this part. I hate that part.
What is that?
No.
is an incoming
closing my
virus
eyes.
attack headed for the cell.
Yeah.
Fortunately, a cloud of antibodies is stationed around the cell to protect it from viruses.
I have my eyes closed.
The white blood cells
I
consume
can't
the
believe
virus,
this is what attacked
as they are
me.
highlighted by the
My
antibodies.
daddy came home from work. He was cooking.
Together, the antibodies and white blood cells form the front line of our immune system. Thousands of viruses have made it past the antibodies. The viruses overcome the
Why?
defenses, and some
Why?
viruses are able to enter the cell using
No, it's not.
counterfeit keys.
And if you guys think it's possible to actually defeat this,
There are too
no,
many
it's a
viruses.
part of the
It looks like the cell is not going to survive.
team.
Let's head back to the observatory.
Oh, boy.
That completes our journey through the human body. We hope you enjoyed the tour.
Yeah, I enjoyed it, but not that part.
Hello, and welcome to the Body VR, an immersive tour through the human body.
That's it for this episode. Guys, see you next episode. But before you click away, subscribe and give a like, and show it to your friends and tell them to subscribe, and tell your friends to subscribe, and tell their friends to subscribe. So I will see you in the next episode. Bye bye.